I'm happy to give the floor to our first speaker, Stanislav Grigoriev, with his topic, Successful Business Applications for Data Science.
Okay, thank you, Anna. Hello, dear friends. If you can hear me, please write something in the chat. Maybe something like plus, if you can hear me. Okay, so we can start right now. So please give me rights to show the presentation, to share my screen. Okay, so please give me the rights to share my screen. Anna, okay. Okay, thank you. So now I'm sharing my presentation and okay. So I'm from Irkutsk National Research Technical University. My name is Stanislav Grigoriev. I am actually associated professor in information technology at Irkutsk National Research Technical University. My topic of research and interest is data science. So I will tell you about some applications for data science and a little bit about our program that actually from one side it is about data science, and from the second side it's about enterprise resource planning systems. So I will cover the first side. It is data science, and my presentation about a successful business application for data science. So what is a data science actually? Data science is a process of building, cleaning, and structuring data sets to analyze and extract meaning. So actually data science is a science. So this is not just a method or maybe just some kind of technique or just the techniques for data analysis. Actually, it's not to be confused with data analytics, which the act of analyzing and interpreting data. These processes share many similarities and are both valuable in the workplace. So if you want to try your hand in data science, it actually requires you to form hypotheses, run experiments to gather data, assess data quality, clean and streamline data sets, and organize and structure data for analysis. So actually these skills you need to have before you can try your hand in data science. Data scientists often write algorithms, so actually they need some skills in programming. In nowadays, most data science using coding in some languages such as SQL or R or maybe Python or maybe other languages to collect and analyze data. When designed correctly and tested thoroughly, algorithms can catch information or trends that humans miss. They can also significantly speed up the process of gathering and analyzing data. Here you can see some representation of data science life cycle. You can see here it actually starting with business understanding. So this is actually a very important part in this cycle, because if you understand your problem, you can move further in this cycle. The next is actually, if you have already some data, the first that you can do with this data, you can find some patterns, something that you can use in future, for example. And this is calling data mining, because this process is maybe very not very complicated, because we have a lot of systems that already can do data mining. And actually, it is a process of gathering and scraping the data that is necessary for the project. The next step, it is data cleaning. If you have data, you need to prepare this data for the analysis. So the next step is cleaning. It means that you need to fix some inconsistencies within the data, and maybe some mistakes, or maybe some things that is actually not could be clear understanding by some other system like artificial intelligence. So data cleaning is very important thing in this cycle, and it is actually some kind of data processing. The next step, it is data exploration. So we have already data, we just clean it up, we just found some patterns in this data. So what we can do with this data next? This is some kind of processing of data that we can investigate it, we can find some useful part of the data, and we can, for example, we can sort, we can use some kind of mathematical statistics, maybe some kind of simple data processing. And after that, we just put this data in some system, So the next step, it is a feature engineering, that actually we already have data, we have cleaned it up, we have explored this data and found something that we can use in our business, in our in some that we are actually doing, some application. And this step is feature engineering. It is for selecting important features and construct more meaningful ones using the raw data that we have. The next step, it is building the predictive model. So this is important thing if we need to analyze in the future, or just make something that with this data, to make something that we can use in the future as a prediction, for example. So for example, if we already found some pattern in this data, we can use this pattern just to predict some other pattern, for example. And predictive modeling, it is maybe already some kind of artificial intelligence application, because in this step, we need to use some kind of mathematician modeling. In nowadays, the mathematician modeling is just going through machine learning, deep learning, neural networks, and everything that we can use for the building models like neural networks, artificial neural networks. So as we have predictive model, we can use it in our practice. We can use it in our project to predict some other new patterns. For example, if we have a pattern that actually describes some sales, some sale problem, and if we after the we build a predictive model, we can use other sales predictions, for example, for our business. The next step is data visualization. Data visualization is the final step for the user of this life cycle, because the data visualization is just showing what we have, what we can do with this, and what we can use in the future with what we have. As you can see, the next step is, again, business understanding. So after we have a data visualization thing, so we just visualized the data, we can do some decision based on this data. And after that, we can adjust our business understanding, or we can just improve, or just maybe build a different system for business understanding. So this is just a life cycle of data science for business. Data scientists, I'm sorry, this is next slide. Data science enables business to process huge amounts of structured and unstructured data that actually calling big data for detecting patterns. This in turn allows companies to increase efficiencies, manage costs, identify new market opportunities, and boost their market advantage. So this is actually the main goal to use data science in business. In our life, in real life, we also have a lot of applications of data science that, for example, asking a personal assistant like Siri on your smartphone for recommendation, that actually demands data science, demands the methods, the techniques, the algorithms that is actually using in data science. So does operating a self-driving car, using a search engine that provides useful results, or talking to a chatbot for customer service. This is actually, these all are all real applications for data science. So we actually already have this. We're already using the data science in our real life, just in methods, just in applications, in our gadgets and everything that we have. So actually, it is already a real life of using data science. So actually, we need to understand the difference between data analytics, big data, and data science. You know, these terms are actually very modern, and we have already maybe 10, 15 years just dealing with these terms. So we actually, when we are talking about data, we can use terms like data analytics or maybe big data. And not all people understand the difference between all this, because it is actually the terms that is connected to some fields, maybe some fields of information technology, maybe computer science, or maybe just mathematics, or different kind of other sciences that we have. So we need to understand the difference between data analytics, big data, and data science. Big data. What do you know about big data? Big data is not just a data that are huge or big. The data that the main thing that is actually we can distinguish big data from the regular data. It is the structure. So, for example, if we have a lot of different unstructured or maybe different structures in the data, we can call it already big data, because we couldn't use a simple algorithm for analyzing this data. Because if you know, the simple algorithm is just can use for some kind of data, for some structure, already known structure of data. So data comes from various sources. Sorry, I'm trying to read chat also. Okay, so if you have questions, you can ask right now in chat, and after presentation you can ask by voice or maybe also in chat. So I'm just showing my presentation. After that, you can ask, or during my presentation in chat. So we have a lot of different data, different structures of data in our life already. Maybe 10, maybe not 10, but 20 years ago, we have not such a lot of types of data that we can use, that we are using right now. Right now, we extremely a lot using, for example, social networks. Social networks consist of different types of the data: text, images, sounds, video, and everything that we actually put in these social networks. And if we are inventing some algorithm for analyzing data from social network, we need to use something comprehensive, something that actually can be used only for this data. So it could be artificial intelligence methods and something else that is actually couldn't be used for the simple data. Data might be unstructured, semi-structured, and structured. So this chart you maybe already saw. It is some representation of growing the data in our world. And you can see here how much data we already have. In 2021, people created 1.7 megabytes of data every second. So you can imagine how much data we are producing every day, for example. By the end of 2022, 44 zettabytes will make up the entire digital universe. So it is a lot of actual data. Here we can see in this chart, we can see 2017 and 125 exabytes, a volume of data that is actually we used in this. And now we have a lot of data that actually growth in these years. Every day, 306 billion emails are sent, and 500 million social networks posts are made. So this is a lot of data. By 2025, 200 plus zettabytes of data will be in cloud storage around the globe. In this chart, you can see also the proportion between unstructured and structured data. So you can see about 80% of data are unstructured. It is actually producing by application, by a lot of applications that we have in our smartphones, in our computers, or other devices that we're actually using in our real life. And all this data are not deleting. These data are storing in some clouds and some archives and some maybe computers somewhere. So we actually not deleting this data. So we are using it every day, and it is storing for the future to make these models for prediction, maybe. Because if you know, for example, Google services can allow you to track your location in every day. So you can find your location, for example, a year ago. You can see where have you been 1 year ago, maybe 1 month ago, so on. So this data actually storing for the future, for analysis, for prediction, for something else. Actually, data science is not one tool, skill, or method. Instead, data science is a scientific approach that uses applied statistical and mathematical theory and computer tools to process big data. Generally, we consider that big data is the raw material used in the field of data science. Actually, we can consider that all data that we have right now are big data, characterizing by its velocity, variety, and volume. Actually, it is the main 3 V's. Big data is a raw material for data science, which affords the techniques for analyzing the data. You can see here is not 3 by 8 V that is actually characterizing the big data. And we have not only the volume, velocity, and variety, we also have here veracity, value, variability, visualization, and viscosity. So a lot of different properties, a lot of different branches, directions, fields of science, of research, projects, and everything that we can direct all our projects, for example, in different directions for this. But you can see the big data is not only the volume. It is a lot of things that is actually consist in this data. So we couldn't say that big data is just a big data, just data that have a lot of different properties. The data mining, the first step in our life cycle, not the first step that is actually giving us something useful. It is a technique used in business and data science, while data science is an actual field of scientific study or discipline. Data mining's goal is to render data more usable for a specific business purpose. Data science, in contrast, aims to create data-driven products and outcomes, usually in a business context. The next thing that is actually dealing with data science, it is artificial intelligence, or just a simple AI. Just means simulated human brain function in computers. The traits that signal this kind of brain function include learning, logical reasoning, and self-correction. Actually, we have 2 types of artificial intelligence. It's like strong and weak artificial intelligence. The strong artificial intelligence means that this artificial intelligence could understand by itself. The weak artificial intelligence, this is just a tool, just an algorithm, just a mathematician model, and everything that actually we have nowadays. We don't have a strong artificial intelligence by now. In the future, maybe we will invent this kind of artificial intelligence that will understand by itself and that could operate autonomously or just by itself. So actually, all our artificial intelligence methods, they're just tools for our different tasks. Also, we have, this is some diagram that is actually showing different fields of data science, just different branches of data science that is actually including in some system. For example, in input, we have data, in output, we have insight. And you can see here is from data, from just raw data to insight, we have a lot of steps. We have a lot of different directions, for example. So you can see here is some part of artificial intelligence in this diagram, in this scheme. It is actually pushes post further. So it means if we have, for example, some mechanism that is calling just a machine learning or deep neural networks that is using using the data to make some models and using this data to get some insight in the future. And you can see here is a data mining that is actually employs this part, and this part is actually enables data mining. Also, you can see here is some parts of data science. We're calling analytics, business intelligence, statistics, and data visualization. And all these parts of data science are actually connected to each other and just working as a system. It's just not a simple science. It's just a system that giving us different things to get finally some insight. Data science and analytics come together when data science is applied in a business setting. Data science helps businesses better understand the specific needs customers have based on existing data. Another thing that is actually a very popular application of data science in business is business intelligence. Business intelligence, it is a subset of data analysis, analyzes existing data for insights into business trends. Business intelligence gathers data from internal and external sources, prepares and processes it for a specific use, and then creates a dashboards with the data to answer business questions. Actually, it is some next step to data visualization, because in data visualization, you get only the diagrams, graphs, charts, and this is very difficult to make to use for making some decision. Business intelligence, it's some kind of decision-making system, or just a part of this decision-making system. So business intelligence is a great and very popular application of data science in business that we're actually using a lot in different, some different things and directions. For finance, the data science is a powerful tool in the fight against fraud, honing the ability of financial institutions to recognize problematic patterns in data faster. So, for example, data science can help reduce non-performing assets, revealing downward trends sooner, and everything else that actually helping to get some decision on some financial problem, for example, or maybe to get some prediction with these financial things. And data science is a very powerful tool for finance. Another issue is using a tools in data science. What languages are better to use for building programs around algorithms, for example, and what tools are better to invent new methods? Actually, we have a lot of different programming languages in data science, but now a lot of applications that is actually are building with only two languages. The most application, not all, but the most application are building with these two languages, R or Python. You maybe know both languages because I hope for your information technology or computer science background. Actually, data scientists need tools for data transformation, data cleaning, and data visualization. These two languages actually could be applied for getting these things. There is also a need to detect outliers, identify relationships between variables, and construct complete interpretive models inside a suitable environment. And this is where data preparation and statistical analysis tools like R and Python come in. You can see here some chart that is actually showing the growing of the interest between two languages, programming languages, R and Python. And you can see the Python languages is actually a bit more popular than R. But as already said, that R programming language is using for some tasks and Python is using for other. Actually, R is a statistical programming language. It is invented for mathematician statistics, for making some algorithms working to calculate some statistical relationships, or just making some algorithms based on statistics. Python is just a modern language. It is a language that is actually using objective-oriented model and could be used for developing an applications. It could be used for different applications as artificial intelligence or visualization. And it is actually very popular for training, for teaching, for understanding the data science methods or understanding artificial intelligence methods. So we can see here is popularity of two languages comparison. Data scientists represent data in form of graphs, charts, and other visualizations. Actually, data visualization it is also the main field inside of data science. That is actually very popular nowadays. We already have some projects based only on data visualization, because it is some development of maybe not an application, but the development of some interfaces. It's like a front-end task to make some maybe just on the level of websites, or maybe just applications for visualizing data that we have in some clouds, or maybe something else. And this data visualization allow users to see insights that are invisible, for example, in Excel sheets of data. And here is some applications of data science that you can see. Here is some directions of applications that we now have in business. The first one is risk modeling. The second is fraud detection. The third is customer lifetime value. The fourth is customer segmentation. The fifth is recommendation engines. And sixth is real-time predictive analytics. So here you can see different directions of applications that we have in business for our in our life. And here you can see some maybe successful business application for data science. The first one is gain customer insights. Data about your customers can reveal details about their habits, demographic characteristics, preferences, aspirations, and more. With so many potential sources of customer data, a foundational understanding of data science can help make sense of it. So this is a first successful application of data science in business. The next one, it is increasing security, to increase security. You can also use data science to increase the security of your business and protect sensitive information. For example, banks use complex machine learning algorithms to detect fraud based on deviations from user typical financial activities. So actually, this is very popular because we have a lot of confidential, sensitive data that we don't want to go it away. The security thing, it is a very important thing in data, in information, and just to in transporting data from one point to other point, and so increasing security is a very important thing. The next one, it is inform internal finances. If your organization financial team can utilize data science to create reports, generate forecasts, and analyze financial trends. Data on companies' cash flows, assets, and debts are constantly gathered, which financial analysts can use to manually or algorithmically detect trends in financial growth or decline. The next one, it is streamline manufacturing. Another way you can use data science in business is to identify inefficiencies in manufacturing processes. So we have a lot of enterprises actually doing something inside their processes, and actually manufacturing machines gather data from production processes at high volumes. In cases where the volume of data collected is too high for a human to manually analyze it, an algorithm can be written to clean, sort, and interpret it quickly and accurately to gather insights. The next one, it is prediction, to predict the future market trends. This application could collect and analyze data on a larger scale, can enable to identify emerging trends in the market. Tracking purchase data, celebrities and influencers, and search engine queries can reveal what products people are interested in. And this is actually the 5 important business application of data science. So thank you very much for your attention. I also want to give you some link. I just will switch my screen just to show some very great book for you, because it will be just a moment. I will switch again to the just a moment. Okay, so I can show you this book. This is very useful and very simple for the beginners of data science. The book is called Data Science for Business, and I will give you a link in chat. You can use it. It is free, actually. You can download it. Download it free. So just a moment. I will try to put it in chat. The link. So this link you can use to get this book. Also, actually, I already have downloaded this book, so I tried to just a moment. Try to if I don't know if I tried to. Yes, I didn't do it before, so I just tried to give you this book directly to this conference. This book is open and free, so you can use. This is unfortunately this book is not mine, but this book is very interesting and very simple to use in your practice, just for the beginners in data science. And this book is about data science for business. Thank you very much for listening to, and if you have any questions, you can ask me, or I'm just will give my rights back to organizer. Thank you so much.